So the question you asked me about is that pentagonal one, right? Let me put it up here.
Yeah, it's the one with the number of dots on set B 1.2, number 4. It's with the equation, because I know I got from my chart the number and then the number of dots. Cool if I write it down on the whiteboard?
Hold on. Put it up here. All right, yeah. Okay. So this is number 4. I want to problem set B.
Set B 1.
This bad boy here.
Yeah, that's the one.
Yep. So the first thing you do is fill it in. And it's a lot like the triangular problem we did, but it's got a little bit of a difference to it. It's, if you fill that table in, what do you guys get? Let's see if I can do it this way. You guys still see it? Yeah. Okay. Everybody get at least this table filled in for this problem?
I did.
Right, because you just had to look at the figures they gave you, kind of continue the pattern.
I got 1, 5, 12, 22, 35.
So it's plus 4, plus 7,
Plus 10,
plus
plus
10.
13, plus 16. Oh,
Yeah.
sorry, I went ahead of myself. 'Cause
So the one we just did with the triangular numbers was n times n plus 1, because every step up was a step of 1, right? Every step I took was, because it went plus 1, plus 2, plus 3, plus 4 between the numbers. Okay.
Yeah.
So this one, let's do two things. So for this problem, let's kind of double these again, like we did for that other problem. 2, 10, 24, 44, 70. Right, because it's sort of like that last problem. And again, if you try to find a pattern here, you might not be able to do it. But if you double it, let's see if we can get this. And remember, it's going to be something like, instead of a step of 1, it's going to be a step of 3. So let's just start with this. If I do this, so it's a step of 3. Every time I go to the next number, I step up 3 more, like a slope. But does it work? For the first number is 1 times 3, 2. No, shit. 2 times, and if n is 2, this would be 2 times 6 is not 10. Damn. All right, so let's take care of the first one. If n is 1, this is 1 times 3. You can tell why I'm leaving some room. What can I do to this to kind of force it to become the right number?
Minus 1?
Yeah. So see if this works. Let's kind of see if this works for the rest of these. So that works for 1. This becomes 1 times 2 is 2. What if n is 2? What's the second number supposed to be is 10. This will be 2 times 3 times 2 minus 1. 2 times 6 minus 1, 2 times 5. Check. All right, and then you can kind of check the next few. And again, I said this earlier when I was helping people out. This problem is one that I'd be very surprised if you're able to get it completely on your own. Right. This part of it, this is part E of that one problem, correct?
Yes.
Okay, so the other ones you could definitely do. This part, very difficult. Now, what do I have to do though? This seems to be the answer so far, but is this for the right collection of numbers? No, because I doubled all of mine, so what do I have to do to this to make it work for these? This works for these numbers. How do I make this work for those numbers? What do I have to do to this? Divide it by 2. So if this was a sequence class, I would have you have a list of different things that could work, And one of them, maybe the 11th thing on our list would be double, triple everything and just see if that helps, right? That would be after you try all these other things.
Yeah, I divided it by 2 just now, and it works.
Sweet.
So,
Okay. So that one, very weird. So I expected questions on that one. All right. Is that all right? You guys got that?
what about 20C?
All right, let's take a look.
Oh, that one. I hated that one.
Oh, so no, part C is the one I was thinking about earlier. That's the one about the number of toothpicks, right? Let me get this down here. Find the total number of toothpicks. So part A, you had to do a sequence of number of squares.
Mhm.
Part B, you had to do a sequence of perimeters.
Mhm.
So part C, you have to do a sequence of number of
Toothpicks.
toothpicks. So the first number in our sequence of number of toothpicks would be what?
4.
4. The second number in our sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9,
10.
12, 13,
13.
right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
13.
Total number of toothpicks. Right, the perimeter one didn't count the interior walls, right? Because I'm only going around the figure. Now I'm counting all the freaking toothpicks. And I've just forgotten what I said. Did I say 13?
Yeah, you said 13.
I gotta write that down before I keep talking. All right, so now it's gonna be,
26.
can you see that this and this is all 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Is it 26? It's like 25. Oh, geez. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's 26. Okay. 26. So this is looking kind of weird, right?
You know the pattern is like plus 9, plus 13.
Do you think that's enough to see the full pattern?
No, because what gets to 9 and what gets to 13. So I did 9 plus 4 and 13 plus 4, and that's how we know that the pattern is adding by 4 to get to the next pattern.
No, we
It's
don't.
like weird.
So here's the problem. It could be you keep adding 4 more, right? But I want to have one more figure. So if I were you, I would draw one more figure and verify that.
Oh, that one I got with a tutor, and I got 64.
For the answer?
No, not the answer.
Oh, for the next one.
But yeah, for the next figure.
Which would really, would that match with adding 4 more each time? No.
I have a question.
Yeah.
I was told to subtract or like work backwards, and then that way you can formulate like the formula.
Work
I
backwards.
don't remember how to
Work-
exactly how to explain it. So like from the full, since from the 9 you would take away 4, so you get the previous number that would be with the 0, and then from then like you do a formula pretty much, and that formula would help with.
All right, so you're assuming that this keeps going up by 4, right? Okay, so that's what I was saying. You want to do one more figure just to make sure. And you're talking about going back a step,
Yeah. That's
which
the-
is actually not a bad thing, but it doesn't really match up
good.
like in reality, because what would that mean? That would mean no toothpicks. That would mean no figures. So that would be sort of a theoretical thing you could do. Yeah. That can help, sure. Yeah, that can help with an equation, sort of. Yeah. So. So I would do one more figure. Make sure this goes up. If this does not go up by 17, then we have an issue, right? Then that's not the pattern.
Oh, I did that.
For that one,
I got 43.
See again?
I got 44 for the fourth figure.
Oh, actually, I got 43.
You would hope it would be 43, because 43 would mean you'd add 17. So you hope it would be 43, so double check. So if you draw the next picture, make really sure about it. I'm pretty sure it does hold, and then the pattern's not that bad.
Yeah, I might.
What's up?
I got
43, okay, all right. Okay.
we didn't technically finish, but I'll turn it in as it is.
All right, now. I gave you 2 more, okay. Thank you. So let's do this, all right. So last time, if you weren't here, we talked a little bit about the idea of different bases. Our system uses base, oh, it is time, isn't it?
Yeah.
Shit, that flies. I love you guys. You're all like, get me the hell out of here. Let me do this. Let me say this. The next test, we're gonna have to push it back at least a day, right?
Yes.
Yeah.
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 I can't believe I didn't get it all into section 2.2. So, has anybody ever done anything with Roman numerals before? You should know how to write like 6. Do you know how to write 6 in Roman?
No. I know one. I
Yeah,
know
a
one.
V and an I.
That's 5.
That's
That's 5.
A V and an I.
No.
Yeah.
That's 6.
Oh.
I know what I'm talking
I
about.
know what's happening.
But then what's an I with a V after it?
Is that 4?
That's 4.
That's- 'cause-
So the Roman numerals are kind of weird. So we're going to start with Egyptian. We're going to do Egyptian hieroglyphic numerals. And then we're going to build up the Roman, which kind of improves on that. All right.